Hello everyone, welcome to video lecture on textile chemical processing, and this is Dr. M. Gopalakrishnan. Before going to today's topic, let's see some pictures related to our topic. So the first one is gray fabric, so that looks duller in shade. And in the second picture, so see the difference between the first and second pictures. There is a difference in whiteness. So the second picture looks brighter and whiter than the first sample. So we have to convert this the first sample into second sample. That means we have to modify the gray fabric into a bleached fabric. That's what's bleaching, and you are going to bleach the fabric, bleach the gray fabric into white fabric. So that's called bleaching. So the aim of bleaching is to make the fabric whiter and brighter. So at this end of this class, you will able to analyze the type of bleaching agent you want to use for bleaching. So that's one. And you can able to measure, or you can able to analyze the amount of bleaching agent required for bleach the particular material, and you can able to modify the recipe, and you can able to alter the type of reagents used for bleaching. And bleaching is one process very important for textile material. If it is going for a full white fabric, that means if the fabric is going for consumers without dyeing, then the fabric needs bleaching. And moreover, we use some optical brightening agent to improve the whiteness of the fabric. And secondly, if the fabric is going for dyeing, if the fabric is not bleached, is it is if it is not bleached, then the dyed fabric looks duller in appearance. So to improve the whiteness or improve the brightness, you have to do bleaching. And thirdly, some impurities present in the fabric that may hinder ourselves, that may reduce the absorbency of the dyes. So it is better to bleach the fabric before dyeing. And the fabric may have some impurities like kitties and motes and seed coat fragments. So these seed coat fragments and motes produce black dots on the fabric. So that may spoil the appearance of your fabric. So you have to bleach the fabric before dyeing. And if it is going for a dark shade like a black or a dark green, then bleaching is not mandatory, but you can do the bleaching to improve the quality of the fabric. So this is all about bleaching. So we'll see in detail. Topic is on bleaching. Actually, after desizing and scouring, still the fabric has some impurities. It may have some natural colors remains in the fabric, so that should hinder your brightness of your fabric. So you have to remove these natural colors from the fabric to get better shades. And the fabric which desized and scoured may have some natural colors, flavons, that is pigment in case of cotton, soil and dirt may be present in your fabric, and Some other fabric, it may be a plant for pots or seeds may be there. And during mechanical processing, it may have some grease and oils. Okay, so you have to remove these impurities. So the objective of bleaching is to destroy the natural colors in the fabric that brings the full white fabric. So this may be necessary for the fabric has to be supplied in white color. So some fabric you need a white color, full white fabric. So for that purpose, you have to do bleaching, and it needs to be dyed in pastel shades. So for example, if you dye the fabric in pastel shades, light colors, then the fabric must be bleached. Otherwise, you won't get the bright shades. And the fabric which is printed need to be bleached. Otherwise, the background is not white. So you have to bleach it for printed fabrics. And if you are going for a darker shades, for example, if you go for going for a dark black or a dark green, so that time I think you don't require bleaching. So sometime it is an optional process, so you can go for bleaching for better bright. Otherwise, dark shades, it don't require bleaching. And the scoured fabric, that means desizing scouring is done on a cotton fabric. After that, the fabric may have some motes, that means a black particle on the fabric, or seed coat fragments. So these are not removed during scouring and desizing. So normally this will be, gives a dark brown or black color, black in color, so that destroy your appearance of your fabric. So these should be removed, and these are removed by bleaching. And normally the dyeing is done on a bleached fabric. If you done in a unbleached fabric, then the brightness of the fabric will be very less. So for better brightness, you have to do bleaching. And sometime they will go for optical brightening agent. So optical brightening agent is will improve the whiteness of the fabric even in normal light. And the absorbency of the cotton fabric may increase due to bleaching. And reduction bleaching and oxidative bleachings are there to bleach the fabric. Previously they used reduction bleaching for silk wool fibers, and nowadays almost all the fibers are bleached with hydrogen peroxide. That means oxidative bleaching. So they are not going for reductive bleaching. So most of the cases they are going for oxidative bleaching. And types of bleaching, so there are two types. One is oxidative bleaching agent, and another one is reduction bleaching. So again, the oxidative bleaching agents are classified into peroxide compounds and chlorine-based compounds. So in peroxide compounds, hydrogen peroxide, sodium hypochlorite, sodium perporate, potassium permanganate, and peracetic acids. So these are comes under peroxide compounds. And for chlorine-based compounds, bleaching powder, sodium hypochlorite, and lithium hypochlorite, and sodium chloride. So these are comes under chlorine-based bleaching agents. For reduction bleaching agents, sulfur dioxide, sodium hydrosulfide, sulfoxylates, acetic sodium sulfite, sodium bisulfite, thiourea dioxide. So these are some reduction bleaching agents. And out of these bleaching agents, three bleaching agents are widely used. One is sodium hypochlorite, NaOCl, and sodium chloride, NaClO2, and hydrogen peroxide, H2O2. So these bleaching agents normally all are comes under oxidative bleaching agents. So these are widely used for textile materials. And the use of oxidative bleaching agents. So in 19th century, before 19th century, that means 18th century, they used sodium hypochlorite, calcium hypochlorite, that is bleaching powder, and that may cause some disadvantages. It is similar to sodium hypochlorite, but it gives some undissolved particles, and it may increase yellowing problems, all those things. So because of that, so the bleaching powder, that is calcium hypochlorite, is not used nowadays. And the discovery of hydrogen peroxide bleaching in 1925 has gradually resulted in replacement of other bleaching process with the peroxide or peroxide based bleaches. And out of these three bleaching agents, sodium hypochlorite, sodium chloride, hydrogen peroxide is virtually replaced all other bleaching agents. Um, if you take hydrogen peroxide, you can bleach almost all the fibers. So that's why it is called universal bleaching agents. And still, the sodium hypochlorite and sodium chloride are used in some developing countries because of the cost factors. And bleaching with the sodium hypochlorite, that is NaOCl, bleaching with sodium hypochlorite, NaOCl. NaOCl is a salt, sodium salt of hypochlorous acid, HOCl. It can be prepared by passing chlorine gas in a solution of sodium hydroxide or by electrolysis of NaCl in an aqueous solution. And sodium hypochlorite is a strong oxidizing agent with a redox potential of 1400 to 1550 millivolt. Cl2 act as an oxidizing agent in the presence of water. It won't give the oxidizing power in dry state. So see the equation, Cl2 plus H2O, it gives HCl plus HOCl. Again the HOCl is converted into HCl and nascent oxide. So this gives the bleaching action, that is oxidizing agent. The formation of HOCl is an important property that provides the nascent oxygen, and that is responsible for oxidation, that is bleaching. So in NaOCl solution in water undergoes the following reactions: NaOCl plus H2O. So NaOCl is sodium hypochlorite, and in the presence of water, it is converted into NaOH and HOCl. This HOCl is a weak acid. In aqueous sodium hydroxide solution has a pH of 11 to 11.5, and due to that the strong NaOH, it is converted to HOCl plus HCl, and it gives nascent oxygen. So in the presence of sodium hydroxide, without the sodium hydroxide, you won't get nascent oxygen. So the pH 11 to 11.5 is very important for bleaching. In acetic medium, the consumption of hypochlorite is very fast and can lead to cellulose degradation by oxidation. So see the reaction NaOCl in the presence of acid. That means in acetic medium, NaCl plus HCl. Again, the HCl plus HCl gives H2O and Cl2. So this Cl2 will degrade your cotton fiber. The conditions like concentration, pH, and time influence the process of bleaching. Generally, cotton is bleached with NaOCl at 1 to 3 GPL of available chlorine. At room temperature, the pH range will be around 9.5 to 11. The effect of pH on sodium hypochlorite bleaching. See the picture or graph. So at pH 5, only the hypochlorous acid will be there, and so at this temperature, at this pH, there is no oxidation and there is no bleaching takes place. So if you reduce the pH, the formation of Cl2 increases the oxidation process, and rapid oxidation takes place, and there is no bleaching takes place on cotton fibers. On the other hand, if you increase the pH above 9, the formation of OCl and the absence of HOCl increases the bleaching effects. That means it reduces the rate of oxidation, and that favors the bleaching of cotton fabric. So that bleaches the cotton fiber. So above 9 is good for bleaching of cotton fabric. And the rate of oxidation of cellulose. The effect of pH on bleaching will oxidize the cellulose fiber. So see the graph. So at pH 7, that means neutral pH, the rate of oxidation of cellulose, it is very fast. Within 10 or less than 10 hours, it will oxidize. That means it will oxidize the cellulose. Whereas when you reduce the pH, it will increase the rate of oxidation, and that's okay for that is slow down the oxidation. And if you see the on the other hand, if you see after 10, the rate of oxidation is very very high. So that means it is good for bleaching. So around 11 to 11.5 is good for bleaching of cellulosic fibers. And see here the fraction of hypochlorous acid. So at pH 10 it is very less, whereas at pH 5 it is almost 1. So that means it will oxidize the cellulose very fast. And see this graph, the degradation of cotton is evaluated by fluidity test with the 0.5 percentage solution, sodium hydroxide solution, barium hydroxide solution. And as you see around 6 to 8, the fluidity rate is very very high. That indicates the degradation of cotton fibers. So you should not do the bleaching at this pH. Okay. So see here at pH 6 to 7, bleaching time is 1 minute. So you can bleach the fabric at 1 minute. So that means rapid oxidation, and the chances of escaping is more, and that will spoil your cotton fabric. And the best condition for bleaching is 9 to 11.5. So at 9 the bleaching time will be around 45 minutes, and 11.5 it will be around 4 hours. So in between you can do the bleaching 9 to 11.5. So if you want, you can if you want to reduce the time, you can reduce the pH. The temperature for bleaching is at room temperature, and the concentration of sodium hypochlorite, you have to keep it at 2 to 3 GPL of available chlorine. The commercial concentration of sodium hypochlorite will be around 40%. That means 400 GPL of available chloride. So you have to dilute the sodium hypochlorite solution for bleaching. Advantages: it is economical, and risk of catalytic damage is very low. So it is more in the case of hydrogen peroxide, and since it is done at room temperature, the energy cost is very low. Disadvantages: fiber damage takes place, and result of formation of AOX. So that is more in the case of sodium hypochlorite, and it will turn to yellow on storage. So that means chlorine retention is more in the case of sodium hypochlorite, that may attract soils, and that turn to yellow in color, and it cannot be used for synthetic fibers. So bleaching cannot be done on synthetic fibers and protein, and it won't give the satisfactory white while bleaching with sodium hypochlorite. So you have to go for a sort of hydrogen peroxide for better white. And the residual hypochlorite need to be removed, otherwise it will open the cleavage, and the chances of yellowing is more. So you have to do the anti-chlor treatment. So normally you have to do it at 2 to 2.5 percentage at 40 degrees Celsius for 15 minutes with the sodium sulfide, bisulfide, hydrosulfide, thiourea may be used, and this is called anti-chlor treatment. And the next one is bleaching with sodium chloride, NaClO2. Sodium chloride is another chlorine based bleaching agent, and it remains stable at high pH, and you have to activate the bleaching agent with acids or acid liberating agents. So if you reduce the pH, it will be activated, and bleaching takes place. The bleaching species for sodium chloride is ClO2 gas, which is liberated at pH below 6. And normally we use some activators to activate the sodium hypochlorite, sodium chloride. So the activators are normally sodium chloroacetate, thioethanolamine, ammonium persulfate. So these are some activators used to activate or used to reduce the pH of the solution. And the active chlorine value are usually determined by the addition of potassium iodide to a sample, and you have to titrate against iodine liberated with the standard sodium thiosulfate solution. Acid like formic acid, phosphoric acid may be used to bring the pH down, and other alternatives are esters like ethyl lactate and dimethyl tartarate, and you can use tartaric or lactic acids. The effect of pH on the composition of sodium chloride liquor. So you see the graph. So when you reduce the pH from 10 to 8, so it start HClO2, and if it is less than 6 liberation of ClO2, so that is the active species for bleaching. So you have to do the bleaching at less than 6. So normally the best pH range is 3.5 to 4. So the shaded one, and this also form AOX, and it is very very less when compared with the sodium hypochlorite. It is only one tenth of the sodium hypochlorite. The redox potential is very less there when compared with the sodium hypochlorite. So it is only 1040 to 1200 millivolt, and the bleaching temperature will be around 90 to 70 to 90 degrees Celsius, and the pH range is 3.5 to 3 to 3 4.5. And the effect of temperature on a sodium hypochlorite is a very gentle bleaching agent. It does not affect the cellulose advice when you increase the pH, when you increase the temperature. So you can bleach at 100 degrees Celsius for several hours. At boil, the bleaching time is very few hours, 1 to 4 hours, and you can bleach even at ambient temperature, but it requires overnight. The rate of bleaching is double for every 10 degrees Celsius. Advantages: it can be used for cotton and synthetic fibers, and since it is worked in a stick medium, it is best suitable for polyester and wool fibers. And you are using a stick conditions, so the hardness of water doesn't influence the process, and it gives soft handle to the material, and it gives better white than compared with sodium hypochlorite, and it gives very little cellulose degradation, and it is insensitive to the presence of metal ions. So the catalytic degradation is not an issue in sodium chloride. Disadvantages: it is expensive than sodium hypochlorite and hydrogen peroxide. It cannot be used to bleach silk and wool, and because it gives pink coloration. And the ClO2 corrode the materials and corrode the metals, and you have to use anti-corrode vessels for bleaching with sodium chloride. ClO2 is a toxic gas, so care should be taken in handling the bleaching process. And since it is working under a stick medium, so the wax removal is not very satisfactory. So again, you have to do the anti-clor treatment for sodium chloride. So you can use sodium thiosulfate or oxalic acid at 85 to 95 degrees Celsius for 10 to 15 minutes. So I hope you have understand the different bleaching agents used for cotton to bleach the fabric, and you have learned the recipe used for cotton bleaching, and you have understand the mechanism of bleaching with the sodium hypochlorite and sodium chloride for cotton material and other synthetic fabrics also, and you have understand the concept of sodium chloride, which is used for bleaching the polyester and blended fabrics, and you have understand the mechanism of chlorine retention and why it is producing the yellowness after repeated laundry. So hope you have learned all those things, and we will see in the next class with some interesting topic. Thank you.